Our next speaker is Dr. Giovani Preza Fontes. He is an assistant professor in the Department of Crop Sciences at the University of Illinois. His research program centers on exploring ways to advance the agronomic and environmental performances of row crop systems in Illinois and the upper Midwest. To do it, his team takes an interdisciplinary approach to document and understand the implications of a variety of in-field conservation practices on crop productivity and profitability, soil and water quality, greenhouse gas emissions, and nutrient losses. This knowledge is then integrated and delivered through the extension program. I'll turn it over to Giovani.
All right. Yeah, good morning, everyone. I'm very excited to be here. I just want to start by saying thank you to NREC for the invitation and be part of the program today. I think that helps keep my attendance streak, I believe, because I was even talking to Julie this morning that I think I attended all the NREC live incitements before, so far. As a student, when I was working on my PhD here, and even when I went away for a couple of years, I made the trip back to attend. So very happy to be here. What I want to do today is just to talk a little bit and tell you guys a little bit about a new project that we started last year at the University of Illinois Dudley Smith Farm. Right, so basically, we are kind of taking a holistic approach to answer a few questions about cover crop species other than cereal rye. But before I do move on, I also want to acknowledge the collaborators and everybody that is involved in this project. I want to make sure that everybody knows that this is a team's effort. It's a collaboration between 3 labs, and we're trying to do it as much as we can to try and answer some of those questions that has been coming up lately. And of course, I also want to acknowledge our funding source, NREC, of course, but we also had additional funding support from the College of ACES through the Office of Research. Just a quick background, because I know everybody should be familiar with this, right? This is a quick review of cover crops in Illinois and the upper Midwest. Cereal rye is the species that we use most, right? There are some reasons for that. It's a winter hardy cover crop, right? So it's kind of easy to establish. It will grow under most conditions. It has a lower seed price compared to other cover crop species. We've done a lot of research, and there's a body of literature showing some of the advantages of having cereal rye as a cover crop. One of them is greater ability to scavenge nutrients compared to other cover crop species. There's a lot of work done in terms of assessing water quality, right? So we know cereal rye has a good potential to reduce soil nitrate losses. And we also see some other agro-ecosystem services, right? So this is an example here that we often see at the farm, the figure there in the bottom, right? So every time we have cereal rye, we do see that visual advantage in terms of weed suppression. However, one of the disadvantages, and I think perhaps the most limiting factor when it comes to adoption, is their potential to decrease corn and soybean yields, right? So again, there's a body of literature there showing that potential of yield impacts. So with that, there has been some questions and I guess a growing interest in terms of, okay, how about other cover crop species other than cereal rye cover crop, right? So if you look at the literature again, we can hypothesize that, okay, if we use some legume cover crop species or other crop mixtures, right, using brassicas and other mixtures, maybe we can have a neutral impact on crop yield, but how about how they impact nitrogen cycling or nitrate losses? It's still unknown, right? So to me, from a sustainability perspective, I think exploring alternatives to cereal rye will require kind of looking at cover crop species that can provide that nitrate loss reductions that we need to meet our goals within the state, but also not compromising other nitrogen losses such as nitrous oxide emissions and the yield of the following cash crop. So that's kind of a quick overview on why we started this. On the figure on your right, you can see kind of our approach, right? So again, this is a collaborative effort So we're taking a holistic approach to try and answer a lot of the questions that we can using the resources available at the Douglas Smith farm. So just to go over a few, right? So of course, we haven't done a lot of research looking at other cover crop species. So there's kind of an unknown territory in terms of, okay, which species are feasible here, how they adapt, right? So looking at cover crop performance in terms of biomass production, biomass quantity and quality. There's also been some questions about nutrient cycling, right? So if you think about these cover crops, they're taking up nutrients from deeper in the soil, kind of recycling them. So, okay, first question, how much of those nutrients are being recycled? And second, can we rely on those to maybe help supply some nutrients to our cash crops? Right, and then of course with the infrastructure at the Douglas Smith farm, we're able to measure water quality in terms of nitrate losses. We're also measuring nitrous oxide emissions as a greenhouse gas. And we're also taking an economic approach to kind of take an economic overview of the adding cover crop species into our cropping systems, right? So just a quick overview. This is the University of Douglas Smith farm, right? So the figure that you see there in the center kind of shows a soil map and our tile drainage layout and pretty much our experimental layout. The farm is located between Payne and Assumption. That's in Christian County, so about an hour and 45 minutes drive from campus. We started a 2-year corn soybean rotation, right? So we had sorted soybean in 2024. If you look at we have 16 plots, and each plot drains individually, so we're able to measure water quality out of those 16 plots. Each plot is about 2 acres each, right? So if you, we do have an auto sampler kind of in each plot that we measure drainage volume and take water samples to analyze for nitrate concentration. There's only so much that you can do with 16 plots, right? If you have 4 wraps, that give us 4 treatments that we can do at a time. So what we decided to do here in terms of cover crop species, we're still keeping a cereal rye as a grass cover crop, right? That's the standard cover crop we have. We went with red clover. We've been having a little bit of success with red clover in terms of fall establishment. So we went with red clover as a legume cover crop. We decided to do a cover crop mixture, and for that we did a hairy vetch plus radish. And of course, we have a no cover crop as our control treatment. These are pictures that we took last fall. You can see that cover crops went quite well after planting. They germinated well, established well. This is often what we see in terms of red clover. There's not a lot of growth in the fall, but given good conditions in the spring, they too then tend to put some decent amount of biomass in the spring. So what I want to do from now on is just show a little bit of what we found in 2024. And again, keeping in mind, this is the first year of data, right? So not digging into too much, but just present what we found last year. So this is a slide showing the cover crop performance, right? So just a little bit of information there. We drilled the cover crops kind of late September. The weather was good. We got good germination before fall. And the cover crops were terminated in April by spraying glyphosate, right? So we're kind of following current recommendations and trying to terminate the cover crops at least the cereal rye when it gets about 1 feet tall, right? So the main reason we do that is trying to control the amount of biomass that we're putting out in the field. In the table here, you can see some of the metrics in terms of performance. It's kind of what we expected to see, right? A lot of biomass for the cereal rye relative to the red clover and the hairy vetch, right? Just because the cover crop, we know that it grows kind of fast in the spring and that have that ability to produce a lot of biomass. But it's still, again, we got decent amounts of biomass for the red clover and the hairy vetch, and you can see the nutrient composition there. In terms of nitrogen, that amount of biomass with the Syrah rye, we had about 37 pounds of nitrogen in that above ground biomass. 14 for the red clover and 23 for the hairy vetch. You can see phosphorus content, it's not that much compared to the other nutrients, right? So potassium also a good amount in the Syrah rye and decent amount in the red clover and the hairy vetch. So in terms of water quality, right, we pretty much need two things to estimate nitrate losses in tile drainage, right? One is you have to know how much water is leaving the field, and you also need to know the nitrate concentration in that water that is being drained, right? So let's start by looking at drainage. So that's what we see here in this figure. This is kind of showing the average cumulative drainage discharge for all of the 4 treatments. 2024, we can say that it was relatively warmer and drier than normal, right? The site only received 35 inches of rainfall throughout the year compared to the 30-year average of 41 inches. We saw a few drainage events in January and February, but if you look at the graph, most of the drainage occurred between April and June. And this is something that we kind of expect to see with that rainfall in the spring. That's when we see most of the drainage being happening. But at the end of the year, we didn't see any significant difference among treatments in terms of drainage. What about nitrate concentration? So this figure here shows the average nitrate concentration, again, for each treatment across the season. One thing that was interesting to see, to me at least, at Dudley Smith Farm, I talked to a few other people and they also see something similar. I think it was very interesting to see that the nitrate concentration in the plots following the Syrah rye was very, very low in 2024. This is, I think, the lowest that we've ever seen, at least at the Dudley Smith Farm. And this is kind of what we would expect to see, right? A lower nitrate concentration with the Syrah rye compared to the other cover crop species. So on average, what we found is that nitrate concentrations tended to be higher with the red clover, followed by the hairy vetch and the radish, and then the lowest with the Syrah rye. And again, if you remember that 80% of the drainage occurred between April and June, right? So that kind of gave us an indication of what happened in terms of nitrate leaching, which is shown in this slide here, right? So the first slide shows the average nitrate losses in pounds per acre for each treatment. On the right, you see the flow-weighted nitrate concentration, right? So that's taking into account drainage to kind of come up with an average nitrate concentration for each treatment. Again, this is the lowest number we've seen so far at the farm, less than 2 pounds of nitrogen being lost with the Syrah rye cover crop. We saw higher nitrogen concentration with the no cover compared to the red clover and hairy vetch, but if you look at the statistics, they were not significantly different than each other. Flow-weighted nitrogen concentration was also very low with the Syrah rye, and it kind of followed the same trend as nitrate loss, right? And kind of put a red bar there that kind of indicates the EPA maximum contaminant level for drinking water. So you can see pretty much all the treatments, even the no cover crop, nitrate concentrations were kind of below that threshold. So there's a few pictures from the site. We have a grad student, Natalia, she's leading that part of the project. So this is a few pictures of them out in the field measuring greenhouse gas emissions. This year we step up our game, so we made an investment and purchased a portable gas analyzer. That's what you see there that Natalia is using. So it's very nice because you take that in the field and you can have kind of an in situ measurements. It's save us time and labor. For my PhD, I did all the manual sampling, so I wish I had that before. But anyway, this is the data for the nitrous oxide emissions, right? So a similar data here looking at cumulative nitrous oxide fluxes over the season. Again, 2024, we had a soybean, right? So and this is actually also the first time that we are measuring nitrous oxide in a soybean at the farm. All the previous projects that we've done was looking at corn in terms of nitrogen management. So one thing that we saw last year was that nitrous oxide emissions were generally low, right? So less than 1.5 kilograms of nitrogen per hectare. And at the end of the season, again, we saw no significant differences among the treatments. So looking at the soybean agronomics, this table here kind of summarizes some of the metrics that we used. Well, yeah, some of the metrics. We collected way more data, but just for the sake of time. So what I'm showing here is the average soybean, right? So one of the things that we were interested to see, and this is based on some of the previous observations from other sites, is that every time we had cereal rye ahead of soybeans, what we found was that soybeans, they tended to grow a little slower, right? So they don't grow that much compared to the no cover crop. So we were interested to see and kind of document if that was the case at the Billy Smith farm. So you can see there the cereal rye kind of reduced the amount of biomass at soybean at the V4 growth stage. And that also, and they also had the lower nitrogen concentration in that tissue. If you look at the R2 soybean tissue nitrogen concentration, that difference disappeared later in the season. But then when you look at the grain yield, we saw a yield penalty when we had the cereal rye ahead of soybeans, right? So this is something that we've seen in other trials. And again, we saw that at the Billy Smith farm, right? I know there's a common perception that soybeans do fine after cereal rye, and sorry to be the bad guy, but I think this data kind of indicates that, okay, maybe that's not always the case, and raises some questions. Okay, can we look further at this and try to understand what's happening on soybeans following cereal rye and kind of develop some management practices that we can kind of overcome that yield penalty. Here's a few pictures from Marcus. He's another grad student that is kind of leading that looking at the residue decomposition and trying to have a better understanding of the nutrient cycling based on the different cover crop species, right? So here we're using a litter bag approach that it's well established, right? So we try to have enough litter bags throughout the season that we can collect that allow us to have a better understanding of how the cereal rye or the cover crop residue decomposes and releases nutrient. So just a little bit of time explaining this figure, because I'm going to show a similar figure for biomass and some other nutrients as well. Again, this is just the first year of data, so I'm not digging into much into it, but just kind of trying to highlight some of the things that we saw. On the first figure on your left, it shows above ground biomass in percentage, right? So you can think about biomass remaining as the growing season progressed, right? So starting at 100%, right? So a quick math there, we had over 1,000 pounds of dry matter for the cover crop species. The dark line kind of models the decomposition rate for cereal rye. The red line there is for the red clover, and the green line kind of models the decomposition rate for the hairy vetch and the radish, right? So this is something that we would expect to see just because of the cover crop species, right? So cereal rye is a grass, they tend to have a higher carbon to nitrogen rate, so they decompose a little slower than having a legume there. Right, so, but it was interesting to see, at least last year, most of the decomposition happened within the first 4 weeks after we terminated the cover crops. And then by the end of the season, we still had a little less than 40% of the biomass left on that residue for all the cover crop species. On the right is the figure showing nitrogen release and being released by that residue, right? So again, nothing that we didn't expect. I mean, we didn't expect to see kind of a faster release in terms of nitrogen as well, but you can see that the hairy vetch released very fast, and most of that nitrogen, at least in the above ground biomass, was released within the first 2 weeks. So we went ahead and also started looking at other nutrients, right? Because we do get a lot of questions about, okay, what about potassium and phosphorus? Can we rely on some of those to supply some nutrients to the crop? So this is what I'm showing here. On the left is the potassium release rate, and on the left is the phosphorus release rate, right? So they follow a similar pattern here. We see a faster release in potassium with the legume cover crop and the mixture compared to the cereal rye. And this is actually what we've seen with the literature, right? So potassium is an ion. It doesn't, it's not part of a molecule, so it leaches very fast in the residue. And if you look at the amount of potassium, right? So we started with about 30 to 37 pounds of potassium per acre. A lot of that potassium is being released within the first 2-4 weeks, I would say, right? So, and at the end of the season, we pretty much have nothing left in terms of the biomass, right? So again, not digging into this too much, but you know, is 30 pounds of potassium enough that we can actually see some differences in terms of nutrient availability? Maybe, but I would say not for potassium, because we don't have a lot of potassium in the above ground biomass, right? So we're only talking about less than 4 pounds of potassium, and they follow kind of a similar trend as the potassium, right? So we see a lot of phosphorus release within the first 2 to 4 weeks after termination. We also like to express losses in terms of crop production. I think using the yield scale approach, it's very good from a sustainability perspective, right? Because at the end of the day, we want to look for practices that are minimizing environmental nitrogen losses, but don't impact crop productivity. So this is kind of a table summarizing everything that we've went through today, right? So if you remember, cereal rye reduced nitrate losses compared to the other cover crop treatments. We saw no significant differences in terms of nitrous oxide emissions. If you look at total nitrogen loss as a sum as nitrate and nitrous oxide, we still see kind of a similar pattern there. Again, we saw a yield hit of the cereal rye on the soybean. So if you look at the yield scale nitrogen losses there, it still tells us that cereal rye is still doing good, at least in 2024, right? So if you look at the yield scale, the lower the number, the better, because it's kilograms of nitrogen loss per megagrams of grain produced, right? So even though we saw a yield penalty with cereal rye, they still showed as being kind of the more sustainable practice, at least in 2024. Again, but we're gonna replicate this study 2 more years, right? So this year we're gonna grow corn, and 2026 soybean again, and then kind of have a better idea of how this cover crop treatments in terms of cover crop species and kind of a holistic approach in terms of nutrient cycling and how they impact cash crops. So,
all right, are there any questions for Dr. Giovani? And thank you. Any questions?
Well, looks like I did a good job.
Okay, if not, I have a question, Julie. All right, so a little bit of a comment and then a question.
Sure.
So I work with a lot of farmers, and I work with several farmers who have been growing cereal rye in combination with soybean and corn for 7 to 10 years. Most of these guys have cattle, so there's a dual use purpose, and that's why they've been growing cereal rye. And they generally, all 3 of them, adamantly refute the data that shows cereal rye reduces corn yield, okay? You know, so I guess in their mind, and in my mind too, is it possible the soil nutrient cycling reaches a new equilibrium with time? Do we think that's possible?
Eventually, yes. I guess how many years it will take, but I've seen a couple of papers discussing and arguing that. unfortunately, we don't have a lot of long-term trials looking at cover crops and corn and soybean yield. But eventually, yes, I think the system might stabilize, and then, you know, with you're incorporating the no-till with the cover crop and having that system balanced, I think it's possible. I just don't know how long it will take, but in theory, I think so.
Sounds like a good NREC project.
I would say the farmer has a strip with no cereal rights, so you can actually compare.
Well,
if
and that's always the problem, right? So, I mean, they don't know. They just adamantly believe that they don't have a yield penalty, right? And I think some of the problem, Giovani, is when, in my geography, when you're getting 275 bushel corn versus 265 bushel corn, well, it was all pretty good, right? So you don't see that 10 bushel yield loss. So I don't know, but I do think it's a good question.
Yeah. Oh, it's a valid question, yeah. I'll be around if you guys want to talk. I'll be around until lunch. I'll be happy to meet you guys and talk to you guys. And thank you again.